Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to be going through Revoscan and talking a bit more about smoothing and simplifying your point clouds and meshes. So in most of the videos we've done, we've kind of left everything a bit raw, and then we've dealt with it in Fusion or some other CAD program. But I think it's important that we at least understand what some of these tools do and make sure that we can figure out how they apply to our models. So this video, we're looking at a sprocket that was scanned using the MetroX, and it was done on a turntable, which means that it's using single shot mode. So the first thing that we want to identify is that the raw data from single shot mode, whether it's on a turntable or whether it's handheld, will have these little camera icons that are going to show us each view that was captured by the scanner. Now, whether or not it's single shot mode or if it's laser or if it's just traditional handheld scanning, you have the ability to do keyframe edits, which allows you to go in and delete and remove individual frames from everything that was captured. Now, with this specific one, we captured 251 frames. Now, that's a lot of data for the sprocket, probably more than's needed, but something that you should really keep in mind is that if you start deleting keyframe data, it's permanent. Unlike making edits to point clouds or making edits to the mesh, you can't back up and undo removing keyframes. That raw data is going to be removed from your project. I'm not sure if that data is saved anywhere in a cache or in your project outside of the scan, but it's not going to be able to be undone like you can do by going up to something and then undoing those edits that you've had. So keep that in mind. You can remove it, but there is a potential problem of loss of data. So whenever you go through the process of scanning something, you always have this one-click option, but generally I go through the Fusion process, manually modifying the point clouds and then doing the mesh edits because I like to have control over what each step is doing. So the first step is always going to be fusing the points together. Now, a recent update of Revoscan has allowed us to reduce the point distance down to 0.05. That's only available on certain scan types for the MetroX, so the full field and turntable, which uses the full field mode. And if you're using something like the Mini 2, you'll be able to now do this down to 0.05. If you're using one of the laser scan modes, or if you have, let's say, a Pop 3 or some other scanner, then those numbers are going to be reduced from what they have been, but it's not going to go down this low. So we're going to apply it using the advanced method. The advanced method will give us a more accurate final set of points. The standard will be a little bit quicker, but there may be more noise in the data. And when we talk about noise, really what we mean is vertical variations in the point location. So you can think of it as like an orange peel or a texture that would be on an otherwise smooth, flat surface. Part of this is going to come from however you prep the part, whether it's scan spray, like in this case, or if it's a shiny part, the actual reflections or the intensity of that shine can have an impact on where those points are. So even though something looks very high polished and very well machined, because of its texture and maybe some settings like the exposure, you may find that you're getting a lot of noise in that data. So the first step is fusion, which is taking the points and averaging them, putting them all together into this 0.05 millimeter distance. That 0.05 is only available if the points captured are closer or that size. So if you do, let's say, a scan and you set the point distance to 0.3 millimeters, you're not really going to be able to see anything down this low on like a laser scan mode. When we're doing the full field mode, we don't have the option to set our point distance. It's going to be just capturing a ton of data. So that's where you're going to see that 0.05 value. So now that we've got our points and we zoom in a little bit, we can see the level of detail that's been captured. The small 16 that's been etched into the surface. Some of these little bumps are actually leftover adhesive from where I removed marker dots. And the texture on this is likely from the scan spray. It's going to have like this orange peel texture that you typically get with spray paint. But scan spray isn't spray paint. It has a carrier like acetone that evaporates and it leaves that powder behind. So the next thing that we want to do now that we've got all the points fused is we want to get rid of all this extra data that we don't need. So we'll select it, we'll hit delete on the keyboard, or you can select delete over here. And then for all these little points, which are marker dots, then we can use isolation. So what this is going to do is it's going to detect basically the grouping of points that are connected, and anything that is smaller than that, that's sort of disconnected, it'll be able to select, and then we can remove it. Overlap detection, this is something that's going to look at points that are above or below, that are basically a little too close together, and we can clean that up as well. All right, so now at this stage, we've got a little bit over 3 million points. 3 million points is quite a lot. And if we go to a mesh at this stage, we're going to end up with 6 million triangles or somewhere in that neighborhood. And that's going to be way too many. So what we want to start to think about is smoothing and simplifying. Now, something to keep in mind with smoothing is that at the point level, we've got strength and we've got times, but the number of points that we have is going to have a direct impact on how well this works. So we should think about the strength value as the ability for these points to move, and the times value is the number of times that we actually go through and rerun this process. So if we have them kicked all the way up, what's going to end up happening is it's going to run through it once. It's going to give it the ability to move the points as far as it can at 20 value, and then it's going to redo that 49 more times. What we're going to see is we're going to get a nice smooth model, but everything is going to be very much like we put this through an oven and melted it. Everything's going to be nice and smooth, but the corners are not going to be quite as tight. So if we consider them as like a fillet, then what you're going to see is they start to get a bit more rounded. You'll notice that the 16 is basically gone, and the ability to move those points up to this 20 value, that was enough to get rid of those points completely. We still have 3 million points, so if we zoom in, we haven't gotten rid of any points. We've just smoothed them out quite a bit. So if we undo that, and we take this strength slider down to, let's say 10, just halfway, and we reapply that. We're going to still go through the same process, but this time with each iteration, it's not able to move the points as much. So this is going to help us start to preserve some more of these details. So when you're doing this process, you need to think long and hard about what information you need to carry on to the next step. So you can see the 16 here, still sort of visible, but it's pretty much gone. So if we undo this, we can reduce the number of times we run through this, let's say down to 20, and we can apply it. So each time it's still able to move those points, you know, that value of 10, the strength of 10, but it's only going to run through it 20 times instead of 50. So it's going to start to preserve some of those details. Probably more than smoothing, you're going to see an effect or an impact on simplification. Now, what simplification is doing is it's taking the number of points that we have, and it's going to go through that process of reducing the overall number. So in this case, if we go down to a ratio of 40%, we're going to take our 3 million to like 1.8 million. So not quite half. If we had this at 50%, we'd go down to about 1.5 million. Using the geometric option is going to keep the density of the points in tighter transitions like corners. It's going to keep the density higher there, but it's going to reduce it in flat areas. The reason that this is important, and I'm actually going to kick this value up so we only have to do it once. I'm going to go to 70%. The reason that this is important is because this on its own can allow us to get a much smoother model. Now, you may need to run it multiple times, and I'm going to run it again. And let's run it one more time. And now what we can see here is we've gone from 3 million points down to 197,000 points. But what's important to note is that in the areas of transition, so the fillets in the corner, the actual spline cut in the center, and around the teeth, we've kept the points much denser in those areas. We've preserved that detail. But what you'll notice is that the 16 is gone. So there is a point in the stage where we are going to lose some data. But going through the process with the geometric settings is going to allow us to simplify this model. Now, the bad thing here is that if we jump in to create a mesh, we're not going to be able to come back and undo this. We have to undo all of our settings. And what I found is that the distance between these points, so let's go into this area here. The distance between these points, this is essentially going to be what our triangle or our distance setting is going to be when we go to a mesh. So I'm not going to go to a mesh at this stage because for a mechanical part like this, it's not really the right choice. But what you can do is you can play around with that on parts like car fenders, and it can be a good option there. So I'm going to go all the way back to 3 million points, and then I'm going to move into the mesh stage. Now with the mesh stage, there is a quality slider that's going to be extremely important. Now with the quality slider, generally what we do is we think about just keeping this all the way up, giving us the best final model. But what that actually means is that all of the noise that has come from the raw point data is going to be captured in those mesh elements. So if we want to really start to think about how much detail is needed, it's a good idea for us to start the mesh process with the quality somewhere in the middle, to apply this and create a mesh. And then once we've created the mesh, if we don't like those results, we can move the quality slider up and we can redo the mesh again. So now that we have a mesh, there is a display setting here to show the wireframe overlay. That's off by default, but it's a good idea to turn this on if you're playing around with this. And what we really want to do is we want to take a look at this mesh. We want to see the mesh element sizes and figure out whether or not we captured all the detail that's important. We can go back to this and turn it to solid. We see that we've got the 16 there. You can see a bunch of lines here, and that's basically the way that the grid ended up working out when it was generating these triangles. But overall, I would say that this captured our design intent. Our number of polygons is 500,000, give or take. So we went from 3 million points, and using the grid size of 0.2 millimeters or 0.5 millimeters is really what we set it at, but it came back with a 0.2 millimeter grid size on the final one, allowed us to reduce the overall file size. So once again, if you're not happy with the results, what you can do is you can increase or decrease this number and regenerate a mesh file, because it's going to go back to the fused points that we have, and it's going to undo the mesh we created, and it's going to sort of work its way back. I'm going to leave it at this because I think this is a pretty good result, but I want to talk a little bit about some tools. We've got this smoothing brush. The smoothing brush works on points as well, but keep in mind that when we're talking about 3 million points, you're not going to see a big difference in what's happening. When we're talking about 500,000 polygons, what we can do is we can use this and we can kind of move it around, and it's going to take a sample size of the points, or the triangles in this case, around what we're selecting, and it's going to allow us to basically reduce those. Now, you'll notice that if I moved over the edge here, I actually destroyed the edge. So we want to undo and work our way back until that edge comes back. We don't want to get too aggressive with this over corners. You can also use Control-Z on the keyboard. And keep in mind that everywhere that you touch with this, every time you left click, or if you hold down the left mouse button and drag, it's going to be creating a bunch of different instances of the smoothing, which means that you're going to have to undo quite a bit. You'll notice I messed up that corner a little bit, but I'm just going to leave it for what we're doing here. So this is good to take care of some of those little inconsistencies. Maybe you've got some marker dots that were left behind, and now we're ready to actually run through and smooth and simplify this model. So I'm not going to worry about isolation or filling holes. I'm going to go straight to smooth. And just like with the points, we've got strength and we've got times. If we leave the strength value at 1, this is giving it the most amount of, or the biggest ability to move these triangles. You'll notice that the 16 is now gone. Now, if I undo that, and instead I take the strength down, but let it run through still 20 times, we are going to get a smoother model. You'll notice that that 16 is still starting to disappear, but overall, the quality of the mesh is still pretty high. Because of the meshing value that we used, that gave us basically 500,000 polygons. You'll notice that these corners look a bit jagged, and that's just simply because of the number of polygons that we have. Again, at any point in time, we can go back and remesh and play around with higher numbers if we want. If we go to simplify, what this is going to allow us to do, and I want to show the wireframe overlay here, but what this is going to allow us to do is it's going to allow us to reduce the overall number of triangles. Again, taking it down to 40% ratio, we're going to go from about 500,000 to about 300,000. And in these big areas, you're going to see larger triangles. And in the corners, we're going to still see those tighter, denser packed triangles. So we can apply this a couple times, just like with smoothing. And eventually what we're going to see is we're going to get a model that has these large, broad areas simplified. And then we've got these areas of tighter transitions with still smaller, denser triangles. And we've gone from, at this point, 500,000 polygons to 100,000. And again, taking that from the original 3 million raw points down to a mesh model that looks pretty good. It's nice and smooth. It still has all the details that we need, but it's down to 100,000 polygons. Makes a big difference if you're going to be reverse engineering and working with this file. And let's say you're working in Autodesk Fusion and you really don't want to bring in a file that has 6 million polygons when you can have one that has 100,000 and still have just enough detail for you to reverse engineer the model or to build something off of it. So I think it is really important that we understand these tools and what they do to our mesh, keeping in mind that anytime we manipulate the point clouds or we manipulate the mesh, we are changing that raw data. But we do have to remember that the raw data doesn't necessarily mean that it's 100% true. We're going to have some inherent noise in the scan, whether it's the surface texture or surface finish or material, the lighting conditions, whether it's our hand moving over the part and introducing some human error. So those are things that we need to make judgment calls on when we're actually processing this data in Revoscan. But at this point, if you're happy with these results, then you can go to export and you can export the mesh model as an OBJ or an STL. Or at any point in time, you could say, well, I didn't really capture enough detail. So I'm going to go back and I want to take this down to 0.1 millimeters, apply it. It's going to overwrite all of the mesh editing that we did. It's going to jump back to that fused point cloud that we processed if we did any smoothing or simplification. And then it's going to go through and it's going to build another mesh model where maybe we've got higher density in the corners. So as we go through the smoothing and simplification process, maybe we're going to keep more of that the raw details and raw data. So the last one that we had was 500,000 polygons. Now we've got 2 million polygons. We can still use the same tools. So we can kind of zoom in here and we can simplify. We can smooth some of this stuff out. Kind of do this manually. I click a couple times, we'll click there, and then we can run through the process of doing smoothing. I'll maybe kick the strength up a little bit. Now, because we've got more polygons, we've gone from 500,000 to 2 million. This means that the strength is not going to have as much of an influence, because if we do our display and we do our wireframe overlay, we have got so many more triangles here that moving each of these triangles up or down a little bit is going to have a very minimal effect on the overall mesh. So if I go back and turn my display off, the 16 is still disappearing, but again, overall, we still kind of have a little bit of a bumpy surface from orange peel. So back to simplify, 40% simplification. In this case, it's not going to go from 500,000 to 100,000. It's going to go from 2 million to, I don't know, maybe 1.2 million or something like that. But each time we do this process, what we're doing is we're manipulating either the points or we're manipulating the mesh data. And you just have to understand, each time I click that button, what does that mean for my data? And is this final result going to be high enough accuracy? What I can already tell you from looking at this one on the screen, as we go through the simplification process, we'll be able to get down to a small polygon number, probably get close to that 100,000 polygons like we had the last time, but our corner detail is going to be much better. We can already see that the corners are sharper, that 16 is still there. There are still some surface inconsistencies to deal with, but I would say that this model at 423,000 polygons is a better model than it was the first time because the quality of the meshing slider was higher and it captured more detail in those edges. So if we go back and we change our display to show the wireframe, you can see that we've got these larger areas, we've got bigger triangles, and then these smaller areas, we've got a tighter density, so it's giving us that edge detail that we might be looking for. So again, the good thing here is that you can always go back and delete all the edits and start over again, or you can go back to meshing and you can remesh this at a higher or lower quality and play around with those settings, making sure that at least you understand what it's doing to your model. Now, at the end of the day, all of the edits that we're making at the mesh level are likely going to have less of an impact to the accuracy of the model than the edits that we make at the point level. In general, unless I've got a good reason, I generally will not smooth or simplify at the point level, and I'll try to reserve that for doing it at the mesh level. Whether it's picking a different quality setting for the mesh or it's picking a smoothing or simplification setting for the mesh. To me, this generally preserves the raw data better than doing something like an aggressive smoothing or simplification. Now, if your end goal is not to try to reverse engineer something or not to preserve mechanical details, if you've scanned something like a statue or a figurine, then maybe doing smoothing and simplification at the point level is perfectly fine for you. But for our purposes, I really just wanted to focus on what these smoothing and simplification tools do at both the point and the mesh level, and give you an example of what you can do with the raw data that we got here, moving it into a fused point, leaving it still a little bit rough. We've got 3 million points here, and then moving into this meshed value. So going back and forth, you can kind of see what the changes are, the corners, and how tight the transitions are, and how things move around a little bit. And again, each of these is going to have some sort of impact on the difference between that raw data and what we're sort of spitting out of the software. So always have to keep that in mind. Now, if you have any questions on this specifically, then please let me know in the comments. As always, thanks for watching, and we'll see you in the next one.